Hey, welcome to The Explainer. Today, we're diving into something you probably use every single day, maybe without even thinking about it, your GPS. But this is about way more than just maps. We're going to uncover the wild connection between your phone and Albert Einstein. Yep, and one of the most brilliant ideas anyone's ever had. So let's just start with this question. You pull out your phone, you open up the map app, and bam, there you are. A little blinking blue dot. How in the world does that little box in your hand know exactly where you are on a planet that's, massive? It honestly feels like straight up magic, but it's actually some seriously cool science. I mean, we all take that little dot for granted, right? It gets us where we need to go, it helps us find a new restaurant, make sure we don't get totally lost in the woods. But today, we're going to pull back the curtain and see the incredible, invisible machine that's working around the clock just to make that dot show up. And what makes it all happen isn't just one thing. It's a whole network. It's like this perfectly timed symphony of 31 satellites, all whipping around the Earth in these super precise orbits, constantly beaming signals down to us. Okay, so you've got this symphony of satellites. How does that actually find you? Well, the first part of the answer is actually pretty simple. It all boils down to some really, really high-tech geometry. So here's how it works. They call it trilateration. First, a satellite way up there sends out a signal with the exact time it was sent. Your phone gets it, and by seeing how long that signal took to arrive, it calculates how far away that satellite is. Cool, right? So now you're somewhere on a huge imaginary sphere around that satellite. Then, a second satellite does the same thing. Now you have two spheres, and where they overlap, that narrows you down to a circle. And then, the magic moment, a third satellite signal comes in, and bam, it pinpoints your exact location. Seems pretty straightforward, yeah? A little geometry, a little clever radio work, job done. But here's the thing. There's a massive hidden catch hiding inside this neat and tidy explanation. And that hidden problem is time itself. This is where things go from simple engineering to something truly mind-bending. Because for any of that geometry to work, one single thing has to be absolutely, perfectly, flawlessly accurate. The timing. It's all about timing. The entire system is built on measuring how long it takes for a signal to travel at the speed of light. So, if your clock is off by even a tiny, tiny fraction, we're talking nanoseconds, billions of a second, your location would be off by a mile. The clocks have to be perfect. So how on earth do you keep perfect time in space? Well, you use something called an atomic clock. These things aren't like the watch on your wrist. They are insanely precise instruments that basically use these super predictable vibrations of atoms as a pendulum. And yeah, every single GPS satellite has one on board. But here's the big plot twist. What if the problem isn't your fancy atomic clock? What if the problem is time itself? Because it's a proven fact of our universe that time is not constant. It actually speeds up and slows down depending on how fast you're moving and how much gravity you're in. And solving that little problem is where our story gets a very, very famous hero. That's right, Albert Einstein. The GPS in your pocket, the one you use to order a pizza, only works because of his theories of relativity. Theories he came up with decades before the first satellite ever left the ground. Without Einstein, your maps would be completely and utterly useless. Okay, so stick with me here because Einstein's theories create two different competing problems for the satellite clocks. First, there's special relativity. The satellites are moving incredibly fast, like 14,000 kilometers an hour. And that intense speed actually makes their clocks tick a tiny bit slower than ours down here on Earth. But then you have general relativity. The satellites are way up high, far from Earth's heavy gravity. And being in weaker gravity makes their clocks tick a tiny bit faster. So you have this cosmic tug of war. Speed is slowing time down, but weaker gravity is speeding it up. So which one wins? Turns out, the effect from gravity, general relativity, is stronger. So when you do all the physics and all the math, the end result is that the clocks on those GPS satellites get ahead of the clocks on Earth by about 38 microseconds. That's 38 millionths of a second every single day.
It sounds like nothing, right? But that tiny difference is everything.
And this isn't just some fun fact for physics class. That tiny little time gap has enormous real-world consequences. Correcting for it is literally what makes GPS work at all. And it's basically a constant planet-wide experiment that proves Einstein's ideas.
Now, I know what you're thinking. Come on, 38 microseconds? That's an impossibly small sliver of time. Does that really matter? Well, let's see.
Oh yeah, it matters a lot. If the brilliant engineers who built this system didn't correct for that tiny 38 microsecond gain, the errors would add up so fast that your location would be off by 10 kilometers. That's over 6 miles every single day. Your phone wouldn't just show you on the wrong side of the street, it would show you in the next county over.
In fact, the error builds up so incredibly fast that the entire global positioning system would be useless for navigation in less than 2 minutes. Just think about that. 2 minutes. Every plane, every ship, every single app on your phone that uses location would just break, all because of a weird little quirk of space-time that Einstein figured out with a pencil and paper 100 years ago.
So the next time you pull up a map and you see that little blue dot, just take a second to remember what you're actually looking at. It's not just a gadget. You are holding a device that is part of a daily, planet-wide experiment that constantly proves some of the weirdest, most profound ideas about our universe are completely 100% true. And that just kind of leaves you with this one last thought, doesn't it? If something as amazing as relativity is hiding inside your phone, it just makes you wonder, what other incredible science, what other mind-blowing stories are hiding in plain sight all around us? Thanks for tuning in.